Good morning to everyone. This is the team from Rashmi Ashram Patti Randala Hardwari Bandha, and here we are showcasing our innovative idea, innovative concept in which we are converting the waste garments pieces into artificial modified silk that is and fire resistant also, that is anti-inflammatory also, and that contains additional characteristic of antibacterial and antimalarial properties too. As we know at these points, this concept, how first of all I would like to tell you how we come to this concept, what is this idea is all about. So as we know, at this point of time, the garment waste or fabric is composing day by day due to the fast changing fashion that is occurring in the modern day period. As we know that people take lots of people wear the garments, sew it, and we know those garment pieces, those fabric is non-biodegradable, and those fabric waste, like I am holding in my hand over here, these fabric waste do not only pollute the environment, but they are degrading the landfill, as well as they are also compromising with our environmental pollution too. So what we have thought, why cannot we recycle these waste garments into a new artificial silk that has more better characteristic than this has, and also it should be more fire resistant. So what we did is that we have taken a lots of waste garment silk like that we have holding in my hands, and as we know they contain cellulose in it. How it is composed, how what it is made up of, so they are made up of cellulose content, right? So what I thought is that I had made a mixture, and or what you can call is a magical mixture, a mixture of 4 gram of copper carbonate that is mixed with 14 ml of ammonia solution. Like you can see, like you can zoom over here also, that it is what? It is a 4 gram mixture of copper carbonate and ammonia. So we have already prepared that solution over here. You can see it appears to be very blue, dark purple in color. Now, what is the characteristic of this solution? This magical solution is that as soon as or as the moment we dip this waste cotton fabric clothes or drop into it, what the solution will do, it will extract all the cellulose from it, and it will form a complex, a cellulotic complex that has the same formula over here, that is a complex formula, right? So what we will do is we will show you by doing this experiment all over around, that we will draw. First we will add a few of the cotton pieces over here. Also we will show you this experiment by adding a cottons to it, and that will reflect how this will convert, how it will extract the cellulose from it and will convert it to a cellulotic fiber. See, first of all, what I am holding is, I am holding a piece of cotton over here. Now in front of you I will add this cotton over this solution. See, as soon as I drop that cotton into it, and now I will compose this mixture. I will mix this mixture truly, and you will see after a minute, in a minute's time, this cotton wool that I have dropped into it, it will be wiped off. Why wiped off? Because the carbonate present over here in this mixture, it will extract the cellulose from it, and that will form a cellulotic fiber. Now, can we have that idea that can we add a cotton only to it? No, we can also add these waste pieces of fabric to it. Like I'm doing it over here, and you will see the result will remain the same. As we are adding the cotton, we waste fibers fabric to it. The result will remain the same, and this at a minute's time, this will also, as soon as I mix the mixture, it will be wiped off, and all the cellulosic fiber will be consumed. I have already added, before making this video, I have already added to it to the 10 to 15 gram of waste cotton fabric to it. So it is fully composed of cellulotic fiber. Now, what I will do is, next I have a dilute sulfuric acid solution. Now this dilute sulfuric acid solution, I will what I will do is I will refill this cellulotic solution to in this syringe needle, and through this syringe needle I will I will show you how the fibers are being made, because this is cellulose copper cellulotic compound that is present over here, and this will form the cellulotic fiber, and that I will show you by the. You have just seen that how the fibers, artificial silk has been created in this dilute sulfuric acid solution. You have just seen that. And when we take, if we wait for 2 to 5 minutes, that blue color artificial silk that has been formed, or the fibers that has been formed, will ultimately turn to white, and that ultimately white fibers will appear like this. We have already collected it over here, and we have dried it down so that it can resemble the fiber obtained from it. It looks exactly like the cotton, but it is also the cellulosic component that is obtained from the waste fabric, right? Now, to add that additional property to it, what I have done is that we have used material. See, we have an aloe vera leaf that I am holding, and we can all easily obtain aloe vera leaves that we grow in our gardens and daily, right? Now, it has an interesting property of antibacterial, antibacterial. People usually used to take their dark spots in their faces down by rubbing it down. Many of them the aloe vera gel that is composed here, it is also used in many of the medicines also. So this has a very great property of being in healthcare, right? In healthcare sector. So what I did is that I have taken the aloe vera gel and I have filled it in over this in the beaker, and to this I have added these artificial silk that I have just obtained from this waste cotton fabric parts by mixing it with the copper carbonate solution. So I have just added these to the artificial this aloe vera gel, and to this I have added a starch powder to it. Now why I have did is this, that I want to add this germicidal, this interesting property of aloe vera to these fibers that we have just created. And to do that, I have added the starch. As we know, starch has a cohesive property, right? What adhesive property? Sorry. So what we do is that it will attach the aloe vera molecules or aloe vera particles to the fibers when it dipped with the starch. And after we keep it for 25 to 30 minutes, and after 30 minutes when we will obtain the fiber, it will be easily equipped or totally fabricated with the aloe vera component as well. So what we have added, we have added an additional characteristic to it. Now after that we will dry this up, and we will make a yarn to it, right? So in our school we have made an artificial just a man-made weaving machine by which we have collected this much of fabric that looks that have exactly been obtained from this copper carbonate solution that looks exactly like this. And when we will then give this yarn to the garment makers or fabric makers so that they could weave it down or knit it down to the modern garments and make a t-shirt out of it, or any cloth, any type of cloth that looks in the fashion industry too. Now to add up to this quality, what we have done one more part is that we have added a fire resistant characteristic to this fabric also. Now, how we did is, as we know at this point, at this stage, we usually used to hear in yearly that in the newspaper most of the time that people get died because of burning. There is a fire rupture, there is short circuit due to which the person got fired and he got died. So many of the casualties that we hear because of the fire, and why it happens, just because the cotton, that the clothes that we wear in our normal days that are not fire resistant, they will attract fire, they attract the fire, and they burns and stick to our bodies, and that causes a lot of irritational burning, and hence the people get tied down. So what we thought is, why cannot we add a fire resistant characteristic to our fabric also? So for that we have done some research, done some interesting part, and we come to the conclusion that we have prepared a solution of borax and boric acid. Now this that I am holding is a mixture of 150 ml of water. Then we added 2 gram of boric acid, 2 gram of borax to it. And to it we have also added a 2 ml of diphenyl oxide. What is the purpose of it? I will tell you later on in this video. So what I did is, like suppose I'm now showing you this by the experiment too. That like this is the some of, like, see, we have a fabric, a waste fabric that I'm holding. Now I have dipped this waste fabric to this solution. Now as soon as I dipped it, I will remain it dipped for it the 5 minutes. I have taken out this fabric from over here. Now it is completely wet. Now we will dry it for 5 minutes. Now, this is our uh, dried fabric that we have taken from this borax solution, right? Now I will show you by the experiment that now this fabric has become fire resistant. How? See, this is the same fabric, but this has not been dropped or mixed with the borax solution, nor it is mixed with the diphenyl oxide. Now, and whereas the fabric that I'm holding in my left hand is been mixed and by totally composed and been dried with the borax solution. Now I will show you by burning. This is the fabric that is a simple fabric. Now without any chemical modification. Now if I burn it, see how quickly it burns, and it burns by clinching and generating a lots of combustion, and this is how the people gets burned, completely burned when they caught some fire accidentally. Now, coming on same fabric that we have just treated with the chemical solution. Now I will show you by burning it over here. As you can see over here, we are burning it by the lighter, but see, it is not catching it. This is the property that we have added by treating it with the borax or a mixture solution. So you can see, as we have shown you experimentally and proved also, that the solution that has been treated with the borax and a boric acid solution and with a diphenyl and a 2 ml of diphenyl oxide mixture, we have got a totally fire resistant fabric. Now, so in the entire process, we have created a fabric by using the waste garment fabric, that is antibacterial property also, that is antibacterial also, that is also in saving our environment, and also it is a fire resistant too. So we have created so much of additional properties by creating this. Now, as I've just told you, that I will tell you why I added this diphenyl oxide, because the inquisitive people will also raise a question that will this borax property of anti-fire of fire resistant, will it get wiped out when this cloth is treated or being washed 2 or 3 times? So for keep this fire resistant property as a permanency, that it will remain to it in its atomic level. That's why this diphenyl oxide is treated. Now, what diphenyl oxide function is that it will mix the boric solution to the particle level, or you can say atomic level of this fabric garments, and hence and it will provide the fire resistant property that will not wipe out, or that will not wipe out by washing or by drying multiple of times. So this is the fire resistant fabric that we have just created. So this is our the entire project is. Now to conclude it, what I will say that in this entire project, just to sum up, that we have saved the environment by changing the lifestyle. How? That we have used the waste cotton fabrics, waste garments that people usually used to throw, that are not decomposable, that harm for our environment also. We have used this to recycle it to a new artificial silk that has so many of additional properties, that have aloe vera characteristic also, that has a fire resistant characteristic also. And now, when we have done this innovation project, we have got certain variable feedback. We have taken a feedback from many of our mentors, many of the other people, and they have questioned one thing, that is the economic viability of this concept. That when the t-shirt, suppose we take an example of a t-shirt, if the t-shirt is made through all this process, how much it will cost? So we have done an entire calculation of it. As we know that a normal t-shirt that a person wears uses 72 grams of cellulose, right? So in order to obtain 72 grams of fabric from it, what we required is a 4 grams of copper carbonate and 14 ml of ammonia solution. Now this will cost us around 200, and the entire summer process, that by knitting, by weaving, by elaborating, and by taking also the account the borax and boric acid prices, the entire cost of the t-shirt for a normal human being comes out to be 430. I know it hurts a bit of 50 or 60 rupees more expensive than a normal t-shirt, but we can compromise it with, we can compensate it with the additional property that this fabric will be having of that aloe vera characteristic, as well as the fire resistant characteristic also. So what I can say is that the fabric that we have made by recycling is a good fabric, a cheaper, affordable fabric, and a healthy fabric too. So this is all our project video is. Thank you.